Chapter 4, moving charges and magnetism. Yes, in last lecture we have discussed about toroid, okay, and some questions based on it. Now in this chapter, in this lecture, we will see force between two parallel currents. The ampere. What is definition of the ampere? See, yes, it is one important topic. Force between two parallel currents, the ampere. Ampere. Okay. Yes, he performed some experiments by taking two wires parallel to each other. Then, such cases in which currents are flowing in the same direction or current is flowing in opposite direction. Then what happens between two wires? We'll see in this video. Force between two parallel currents. I am taking two parallel wires like this. Infinite wire. Two parallel wires like this. Infinite wire. I am taking coordinate system. Let it is origin. It is x-axis. It is y-axis. Clear about this? Two wires. It is one wire and it is another one. Clear about this? Yes or no? Yes, it is. Okay. Z-axis is perpendicular outside. Let current flowing from this is I1 and current flowing from this is I2 in same direction. In same direction. So, two long wires carrying current I1 and I2 in same direction. In same direction. Parallel to each other. Yes, two long wires carrying current I1 and I2 in same direction. Parallel, and yes, at distance d apart. At distance d apart. Yes, distance between them is d. Clear about this? Now see what happens, how force is acting between two currents. Yes, see, I am taking this first wire. Okay, first wire. Current flowing from this first wire is I1. Current flowing from first wire is I1. Current in first wire is I1. So yes, we can say this current carrying conductor. So due to this wire, magnetic field produces. Yes or no? I have to find force acting on this wire. Wire number 2. So I have to find what is magnetic field on this wire due to this first wire. So see, magnetic field due to first wire at distance d. And distance d means on this wire too. What is the equation of magnetic field? D is equal to, it is mu zero I upon, it is 2 pi d. If you remember equation, D is equal to mu 0 I upon 2 pi d. Yes, it is vector. So here we have the right direction. See how? Here it is. I is flowing in this direction. Current is flowing in this direction. Second wire, it is in upward direction. So you have to wrap fingers in this direction. Thumb is outside. Clear about this? Again. Current is flowing in this direction. Yes or no? Second wire is above this wire. Then wrap fingers in this direction. Thumb is coming outside. Outside means in direction of z-axis. Means it is k cap. Clear about this? It is k cap. So it is mu 0 I1. Yes, it is mu 0 I1 because current flowing from this is I1. B is equal to mu 0 I1 upon 2 pi d k cap. Clear? Okay. So yes, take first wire. Current in first wire is I1. So magnetic field produced due to this wire is B. Okay. Now, let current element on second wire, on second wire, having length L, then what is current element? IDL means what? IDL means it is current flowing from this wire is I2. See what I am taking. I am taking one element of this wire. I am taking one element of this wire. Okay. So yes, what is current flowing from this I2? And if I am taking this element having length L. Clear about this? Okay. So IDL is equal to this I2. Its length is L. And see, this current is flowing in this direction. Means I can write it is I caret. Clear about this? IDL current element is equal to I2L I caret. Clear about this? Let current element on second wire having length L. IDL is equal to I2L I caret. Clear about this? Any doubt? Okay. Yes, I can name this magnetic field as V1 because it is produced into this first wire. Again, I am repeating my mind. First wire, current in first wire I1, magnetic field due to first wire at distance d V1 is equal to mu 0 I1 2 pi d k caret. Now I am taking second wire, one element on it having length L, then IDL is equal to I2 L cross I. So now due to this magnetic field, what is force acting on this current element? Okay, force acting on current element. F is equal to, yes, we have one equation that is IL cross B. Here how to write this equation? Here F is equal to IL means it is I2L I caret cross. What is B? B means this B1 means it is mu 0. B means this B1. Yes or no? B means this B1 mu 0 I1 upon 2 pi d, and here it is K caret. Clear? So yes, F is equal to, here it is. See, mu 0 I1 2 pi d I2L. This each and every quantity is scalar. So I can write like this: mu 0 I1 I2L upon 2 pi d. In bracket it is only I cross K. And if you remember 11th chapter number 4 vector product, I cross K is equal to, yes, it is minus J. So how to write force? F is equal to, it is mu 0 I1 I2L upon 2 pi d. Here it is minus J caret. It is force acting on wire number 2. Clear about this? Okay. Yes, if I write force per unit length, okay, if force per unit length, then how to write? Then I can write this as F2 upon L is equal to, it is mu 0 I1 I2 upon 2 pi d, and here it is minus J caret, Clear about this? Now see in figure, here it is minus J caret means what? This force acting on second wire is in minus J caret, means negative y direction, means on this element force F2 is acting in this direction. Clear about this? Okay, so yes, first wire, current flowing from first wire is I1. Due to that magnetic field is produced. In this magnetic field there is a second wire. So what is force acting per unit length of second wire? F2 upon L is equal to mu 0 I1 I2 upon 2 pi d minus J caret. Means in this direction. Now similarly I can find what is force acting on first wire. See in short how to write. Okay, second wire, let Current flowing from second wire is I2. Yes, you know what is current flowing from second wire? It is I2. So yes, magnetic field. What is magnetic field? B2. B2 is equal to magnetic field. B2 is equal to, yes, we have equation mu 0 I2 upon 2 pi b. What is direction? See here, what is direction? I2, it is in this direction. Yes or no? Now this wire is below it. Below it means we have to wrap fingers in this direction. Again, I2 is in this direction. Yes or no? Yes. Second wire is below it. So you have to wrap fingers in this direction. So thumb is moving in perpendicular inward. Perpendicular inward means minus z-axis. Means I can write it as minus k. Clear about this? Clear about this? Now take element on first wire having length 1, having length L. Okay, then what is current element? IL is equal to I1 L. I caret, because current is flowing in x direction. Clear about this? Then what is force acting on first wire? Force acting on first wire. I can write that F is equal to F1 is equal to, it is IL cross B. IL, it is I1L, I direct cross. What is value of V2? It is mu 0 I2 upon 2 pi B, and here it is minus A direct. Any doubt? Again, I can write mu 0 I1 I2 L upon 2 pi D, and yes, this minus sign. Again, I cross K. Again, I cross K. What is I cross K? Yes, I cross K is again minus J. But minus J and this minus, it will become positive. So yes, your answer is mu 0 I1 I2 L upon 2 pi D, and here it is J caret. Okay, that is F1. And if I find force per unit length, F1 upon L, then it is mu 0 I1 I2 upon 2 pi D J caret. Now what is meaning of J caret? Force acting on first vector. J caret means in direction of positive y axis. Here it is on this first wire. Force is acting in positive y direction, means in this direction F1. Clear about this? Force acting on second wire is in this direction. Force acting on this wire, it is in this direction. From this you can easily say these two forces are towards each other. Towards each other means attractive force. So what is conclusion? When you have two wires parallel to each other, currents are flowing in same direction. They will attract each other. So yes, you have to remember this result. If you have two wires and if current is flowing in same direction, okay, then there is attractive force between them. Okay, now see this figure. I1 and I2, they are in same direction. If you reverse current in any one wire, and if you repeat this calculation, you will be on one result. It is F1 and F2. See, this F1 and F2, this F2 will be in this direction and this F1 will be in this direction. Okay, means they are moving away. Away means repulsive. So when current is moving in opposite direction, currents are in opposite direction. They are in opposite direction. Then yes, there is repulsive force. There is repulsive force. Clear about this? Now observe equation. See, force per unit length on second wire. mu 0 I1 I2 upon 2 pi d minus j caret. Minus j caret indicates direction. What is magnitude? Mu 0 I1 I2 upon 2 pi d. Okay. Now, force acting per unit length of first wire. What is the equation? Mu 0 I1 I2 2 pi d j caret. J caret indicates direction. It is magnitude. See, in both cases, magnitude is same. See, in both cases, magnitude is same. So yes, what is conclusion? If you have two wires having current I1 and I2 separated by distance d, then force per unit length is mu 0 I1 I2 upon 2 by d upon 2 by d. If currents are flowing in same direction, there is attractive force between them. If currents are flowing in opposite direction, repulsive force between them. Clear about this? Okay, so yes, it is one important theory. What is force between two parallel currents? The ampere. The ampere means what? See, here it is. If in this equation you put value of mu 0, that is 4 pi into 10 raised to minus 7. I1 1 ampere, I2 1 ampere, 2 pi as it is, and d also 1 ampere. Clear about this? Value of L also 1 ampere. Mu 0 4 pi into 10 raised to minus 7, 1, 1, 1 and 1. Then what you will get? You will get F is equal to 2 into 10 raised to minus 7 Newton. F is equal to 2 into 10 raised to minus 7 Newton. So what is meaning of this? How to define ampere? See, here it is. If I have two wires placed parallel to each other at a distance 1 meter, and if force acting per unit length, L is equal to 1 meter, force acting per unit length is 2 into 10 raised to minus 7, then current flowing from each wire is 1 ampere. Then current flowing from each wire is 1 ampere. So yes, it is definition of 1 ampere. Again, if I have two wires placed parallel to each other at distance 1 meter apart, then force acting per unit length is 2 into 10 raised to minus 7 Newton. Then current flowing from these wires is 1 ampere. Yes, it is 1 ampere. So now check your textbook of 11th Physics Part 1, Chapter number 2, Fundamental Quantities, 4th number, current, its unit ampere, symbol A and definition. Yes, you will get this definition. Clear about this? Okay, so yes, what is tidal force between two parallel currents? What is definition of current? This result is important. Current in same direction attractive, currents in opposite direction repulsive, and this ordinary equation. Force per unit length is equal to mu 0 I1 I2 upon 2 by d. Clear about this? Right now. Now we will see some questions. See, example 4.10. Earth behaves as a magnet and its magnetic field, horizontal component, B at 3 into 10 raised to minus 7 Tesla, is from geographical south towards geographical north. Okay. Very long wire carrying current I is equal to 1 ampere, okay, is placed on horizontal table. Okay, you have to find force per unit length when current is flowing from east to west and south to north. Okay, what is equation of force? Equation of force on a wire in magnetic field. In magnetic field, F is equal to IL cross P. If I want to find its magnitude, I can write F is equal to ILP sin theta. Here we have to find force per unit length, means F upon L is equal to, it is IE sin theta. Clear about this? Okay. Now, first case, when current is flowing from east to west. Current is flowing from east to west. Now see, east, west, north, south. Magnetic field BH is from south to north. Yes or no? Is from south to north. South to north means that magnetic field is in this direction. Yes or no? South towards you, north towards me. It is south to north. Yes, current is flowing from where? From east to west. East to west means in this direction. Clear? Means they both are perpendicular to each other. So what is angle between them? Angle between them is theta is equal to, it is 90. So yes, F upon L is equal to IB sine 90. Sine 90 is equal to, it is 1. So yes, it is only IB. What is value of I? You are given. What is value of me? Yes, you are given. So it is 1 into, it is 3 into 10 raised to minus 7. So yes, it is 3 into 10 raised to minus 7 Newton per meter, because it is force per unit length. Question B. When current is flowing from south to north. Again, magnetic field is always from south to north in this direction. Yes or no? Yes, it is. Now current is also flowing from south to north, means in this direction. See, these two chalks are parallel. Yes or no? It is magnetic field south to north. Current is also flowing from south to north. So what is angle between them? Theta is equal to 0. Then force per unit length, it is IB. Here sine 0. Sine 0 is 0. Then what is force acting on it? 0. Force acting on it is 0. Clear about this? So yes, this magnetic force depends on angle. Next question. Next question. Exercise 4.5. Find force per unit length on a straight wire carrying current 8 ampere. Placed at angle theta is equal to 30 degree with magnetic field B is equal to 0.15 Tesla. Simple question. Force acting on wire F is equal to, it is IL cross B. Its magnitude F is equal to, it is ILB sine theta. Understand question? You have to find force per unit length. So force per unit length F upon L is equal to, it is IB sine theta. You are given value of I, you are given value of B, and you know what is value of sine theta. You can easily calculate this question. Clear? So yes, one important theory and two very easy, very simple questions. Okay? Yes, students, as you are in 12th, it is one important year for you. So watch your videos regularly, make notes, solve your doubts, and yes, do subscribe, like, share and comment on